In C programming language, there are several data types commonly used in embedded systems to represent different kinds of data and to efficiently utilize the limited resources of such systems. Here are the various data types frequently employed in embedded C programming. 1. Integer types. Char represents a character or small integer. Its size is typically 1 byte. Represents a short integer. Its size is usually 2 bytes. Represents an integer. Its size can vary depending on the compiler and platform, but is typically 2 or 4 bytes. Represents a long integer. Its size is usually 4 bytes, but it can be larger on some platforms. Variants. These represent non-negative values, effectively doubling the positive value range of their signed counterparts. 2. Floating point types. Represents a single precision floating point number. Typically occupies 4 bytes. Represents a double precision floating point number. Typically occupies 8 bytes. 3. Bit field types. Represents a single bit. Often used for efficient storage of binary flags. With bit fields, allows the allocation of specific numbers of bits to represent various values compactly. Enumeration types represents a set of named integer constants. It provides a way to define symbolic names for a finite set of values. Pointer types represents a memory address. Pointers are extensively used in embedded systems for efficient memory access and manipulation. 6. Void type represents the absence of a type or an empty type. It is commonly used as a return type or for function arguments when there is no value to be returned or passed. 7. Derived types allows the creation of user-defined data types by assigning new names to existing data types. 8. Other data types. Platform-specific or compiler-specific data types may exist in embedded systems such as, and so on, which provide fixed-size representations for efficient memory usage. It's important to note that the sizes of these data types may vary depending on the platform, compiler, and specific requirements of the embedded system. It is essential to refer to the documentation and specifications of the target hardware or consult the compiler documentation for precise data type sizes.